NASA's IceNode mission, pioneering robots to chart Antarctic ice melt and predict sea level rise. In a groundbreaking initiative that could revolutionize our understanding of climate change's impact on global sea levels, NASA's Jet Propulsion Laboratory, JPL, has taken a significant stride forward with its IceNode project. A pioneering endeavor, IceNode entails the development of a fleet of autonomous underwater robots capable of traversing the hidden depths below the polar ice, specifically the Antarctic ice shelves, to determine ice melt rates with unprecedented precision. The idea was given a proof of concept reality check when JPL engineers tested their prototype robot in the harsh conditions of the Beaufort Sea, located north of Alaska. This operation marked the first polar fieldwork for the IceNode project. Braving temperatures as low as -50 degrees Fahrenheit, the cylindrical robot was lowered into the ocean through a slender borehole, linked by a tether that provided control and power. It successfully collected valuable test data, such as salinity, temperature, and flow metrics, from approximately 330 feet beneath the sea surface. The ambitious vision for IceNode responds to a pressing scientific need. Antarctica's ice sheet holds the equivalent of 200 feet, 60 meters of sea level potential to melt entirely. Yet, the intricacies of ice shelf melting, an important indicator of how quickly the continent is losing ice, are poorly understood, obscured beneath miles of ice, beyond the reach of satellites and direct human access. At about 8 feet in length and 10 inches in diameter, the proposed IceNode robots are envisioned to navigate these perilous and uncharted waters. Using specialized software to make use of ocean current models, the robots will latch onto the ice, taking advantage of the natural flow rather than using any form of built-in propulsion. This innovative mechanism will enable the robots to travel autonomously to the grounding zones where the ice, land, and sea interact dynamically. Specifically, they will anchor to the underside of ice shelves to directly gauge the interaction between the warmer saltwater and the colder freshwater from melting ice. The data IceNode robots gather will significantly enhance the accuracy of computer models used for predicting sea level rise. Continuous data acquisition over periods up to a year, including seasonal fluctuations, will substantiate scientific understanding of the polar ice melt rates. JPL's strategic development of IceNode leverages the lab's deep experience in robotic engineering, previously applied to extraordinary successful space explorations. This terrestrial application, however, brings its unique set of challenges, witnessed by the hardware and team during their Arctic testing through the U.S. Navy Arctic Submarine Laboratory's Ice Camp. While some obstacles still remain for IceNode, including fine-tuning the off-tether operation and enduring prolonged deployments in extreme environments, the progress has been positively appraised by the JPL team. The promise of garnering long-sought data on sea ice interactions intensifies the anticipation for future deployments. Backed by JPL's internal research incentives and its Earth Science and Technology Directorate, IceNode represents a significant leap towards acquiring reliable data. Data that is essential not just for the scientific community, but for the global populace, as it grapples with the realities and projections of climate-induced sea level changes. Thank you for choosing Satori News.